All right, question 81. So Rawl had imagined the spinners were divided into equal parts before he saw them. He created the probability table at the right to organize the outcomes. Yep, just kind of like we did here. I thought there would be 1/3 chance of spinning a 3 on spinner 8, but now that I see the spinner, I know that's not true. I need to make a new rectangle in order to find the probabilities. So part A, create a new rectangle, label the top row and left column with numbers of each spinner and their probabilities. All right, so let's make our table. So we're going to make it over here and get me out of the way. So let's see. I've got my table. All right, and let's see what we got going on here. So let's make them into pieces, I guess. So we've got 3 numbers here, and we had 3 numbers going this way. All right, so I know when I did this that I could get a 3, and if I got a 3, I had a 3/4 chance of getting a 3. All right, on that same spinner, I had a 2, and I had a 1/8 chance of getting a 2, and of spinning a 4, I also had a 1/8 chance. And those numbers come from the previous question when we looked at it. Remember, these two made up 25% of the spinner, so we split them in half, which would be an eighth and an eighth, which is 2/4, which is the same as 1/4. On my other one, we could have gotten a 6, and that had a 1/3 chance. I could have rolled a 7, and that had a 1/3 chance. Or I could have rolled an 8, which has another 1/3 chance. All right, so there's my new rectangle. Part B, write a multiplication problem to show the probability of spinning a 3 and a 7. So here's my 3, here's a 7, so I'm going to fill in this right here. So my multiplication problem would be 3/4 times 1/3. So 3/4 times 1/3. Remember, that's a 4. 3 times 1 is 3. 4 times 3 is 12. So I have a 3/12 chance of getting a spinning a 3 and then a 7. So that is 3/12. All right. So I calculated the probability of spinning a 3 and a 7. I have a 3 out of 12 chance of getting a 7. Complete the table to show the probability sum of and its probability. All right. So let's see. So I'm going to go through and do the probabilities first and then kind of put in what they equal. So let's see. 3/4 times 1/3. Well, I know all these are going to be 3/12 because they're all the same one. 3/4 times a third. So these are all 3/12. All right. And here I have an 1/8 times a third. Well, let's see. 1/8 times 1/3 is going to give me 1/24. So I know all of these columns are going to be 1/24 because every single one of these is 1/8 times a third. Then 8 times a third, once again, is 1/24 and 1/24. And then this is also going to be 1/24 because it's, again, 1/8 times a third. So that is 1/24 and 1/24, and now 1/24. All right, now I'm going to go back and I'm going to add in what I would get. So if I did this, I would have gotten a 9. This would have given me an 8. This would have given me a 10. Add these together, we would have gotten a 10. We would have gotten a 9. Add these together gives me an 11. That was an 8, so that would have given me an 11. This would have given me a 10, and this would have given me a 12. All right, so reminders. The blue numbers is what I get when I add up the numbers. All right, 2 and 6 gives me 8. Those are the blue. These here, these are the probability of getting that number. So the probability of spinning 2 spinners and add them together and get a 9 is a 3/12. All right. So what do we got going on now here? Complete the table. All right, we did that. So what is the probability of spinning an odd number? All right. So an odd number. Well, let's see. This is odd. So I have a 3/12. Hold on. I want to erase some stuff to give myself some room to work. Come on. There we go. All right. So let's figure this out. So here's an odd number, and I would have a 3/12 chance. Here's an odd number. I have a 1/24 chance. Here's an odd number, another 1/24 chance. Another odd number gives me 3/12 of a chance. And that is it. All right, so what's my chance of doing an odd number? We got to add these together. Well, 3/12 and 3/12 gives me 6/12. And now I need to add them to these numbers. So I need to get a common denominator. It gives me 12/24. So now when I add these up, I get 13, I get 12, 13, I get 14/24. So there definitely is a better chance of getting an odd number than an even number. So the probability of an odd sum is 14/24. What's that reduced down to? 7/12. So I have a 7/12 chance of spinning an odd number. So what's the probability of an even number? Well, that would be the rest of it. So that would be 5/12. So now that I see these next to each other, there's definitely a better chance of spinning an odd number than there is an even number. Did you make the right choice of odd or even? Well, if it's you guys, yes, because you chose odd. Me choosing even was not correct. And since I told you guys which ones to take and I gave you guys the odd, that definitely is not the right choice on my part. But notice how, because the spinners were different sizes, it really kind of changed this. So notice our probability table kind of changed. Anytime we want to make a probability table like this, we have the chance of it happening, the chance of it happening, and then we would multiply. So all these years that we've been doing generic rectangles, we were kind of getting ready to do stuff like this. We were setting you up to make a probability table. So hopefully this